Find the sine of A, sine of angle B, cosine of angle A, and cosine of angle B. Write each answer as a fraction and as a decimal rounded to 4 places. All right, so we have 4 different pieces here. So let's just start with our sine of angle A. So I'll write sine of angle A. And remember that, so here's angle A right here. My sine is always going to be based on the SOHCAHTOA idea. So let's write that. My sine is always my opposite side over my hypotenuse. So with respect to angle A, opposite that would be this segment BC right here, which I know is 15 units. So the sine of angle A is equal to 15 over, my hypotenuse is always directly across from my right angle. So in this case, my hypotenuse is this segment AB, which is 39. So the sine of angle A is 15 over 39. And we can reduce this. We can simplify this fraction. We can divide the top and the bottom by 3. 15 divided by 3 would just be 5. And 39 divided by 3 would be 13. So the sine of angle A is just 5/13, 5 over 13. So that takes care of the fraction, but we don't have the decimal yet. So we need to just type into our calculator 5 divided by 13. And you want to make sure that you round this correctly. So let me pull up my calculator here. And if I do 5 divided by 13, and we get 0.38461. So notice that this one here is not going to require us to round this up. So this is just going to be 0.3846 when I go to 4 decimal places. And we're going to say that that's approximately 0.3846. One down, 3 to go. Sine of angle B. So here's angle B. Once again, I'm going to do my opposite over my hypotenuse. So opposite angle B would be this 36. That's segment AC. And my hypotenuse didn't change. That's still 39. Just like our last fraction, we can simplify this. We can reduce this. We can divide the top and the bottom by 3. And 36 divided by 3 is 12. 39 divided by 3 is 13. And now we have this simplified. So the sine of angle B is 12/13. That takes care of the fraction. We still need the decimal. So let's pull up my calculator. And I'll clear this out. 12 divided by 13. And it looks like we got 0.92307. So this 7 is going to round this 0 up to a 1. So rounded to 4 decimal places, we have 0.9231. So this is approximately 0.9231. 2 more to go. The cosine of angle A. So from our SOHCAHTOA, our cosine is our adjacent over our hypotenuse. So if here's angle A, adjacent to that would be this 36. And my hypotenuse is still 39. And this looks familiar. 36 over 39 we just dealt with right here. That simplifies down to 12/13. And we already know from what we got with the sine of angle B that in decimal form, 12/13 will be 0.9231. No need to type that into our calculator twice. It's the same thing. And this shouldn't be a surprise to you because with respect to angle B, when we're working out our sine, the side that is opposite angle B is this AC. With respect to angle A, when we're working out our cosine, notice that our adjacent side with respect to angle A is the same side, this AC or this 36. So whether I'm looking at the side that is opposite this angle or the side that is adjacent to this angle, in both cases I'm dealing with 36, and of course my denominator is always my hypotenuse, always 39. So you should notice a little pattern here, and that is that anytime you take the sine of this angle, sine of angle B, that's going to match up with the cosine of angle A. We got one more to go, and that's our cosine of angle B. And so here is angle B. With respect to angle B, remember cosine, we're dealing with adjacent over hypotenuse. So our adjacent side would be 15. And our hypotenuse is still 39. And look at that. 15 over 39 came up right here with the sine of angle A. So we already know that the simplified version of the fraction is 5/13. And we already know from up here that the decimal version is 0.3846. Just like previously, this shouldn't be a big surprise. Let's look at why this is happening. When I dealt with the sine of angle A, so with respect to angle A, my opposite side is this 15. When I dealt with my cosine of angle B, the adjacent side with respect to angle B is once again this 15. So you're dealing with the same exact side. So to summarize, the angle opposite, or the side opposite angle A and the side that is adjacent angle B are going to match up. So in all of your right triangles, you're always going to see these two things represent the same exact ratio. And let's just pull this box away to see our answers here, make sure we got all this correct. So the sine of angle A is equal to the cosine of angle B, which is 15 over 39, or 5/13, decimal form 0.3846. The sine of angle B is equal to the cosine of angle A, 36 over 39, simplified down to 12 over 13, 0.9231.